Hello, 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 hello. Okay, then let's start the session. So as you all know that now you can prepare for Maharashtra State Board exams with Unacademy, right? Many batches have already started. Full syllabus will be covered. You will be taught by top educators of HSC and SSC and HSC. Languages is delivered in Hindi. The lectures are delivered in Hindi, English or Marathi. So you can attend the lectures. You can just enroll for the batches, and you know the lectures that will be of your language of choice, right? Now this is my profile. This is Sagar Jha, your physics educator on Unacademy. I have completed my M.Sc in physics from IIT Jodhpur, and I have been teaching students like you for more than 6 years, right? You can use my code SIR SIR. If you use this code to join any of the batches on the plus course on Unacademy, you will get a 10% discount on it. So please don't forget this code SIR. So taking a note of that, let's start our session on kinematical equations of circular motion. Okay, so we'll be talking about kinematics of circular motion today. Okay, kinematics of circular motion. Kinematics of circular motion. Now first, let me just tell you what is this kinematics, what is the meaning of kinematics, and then you know circular motion we have already discussed what is circular motion. So we all know about circular motion. We all know that in case of circular motion there is a force called centripetal force which is responsible for circular motion. Now in this case we are going to be discussing about kinematics. See, we have already discussed certain angular quantities and we'll be having some relations, and today we are going to talk about kinematical equations of circular motion. Kinematical equations of circular motion. We have already started discussion on the topic of kinematics because in the last session we had discussed angular quantities, right? Certain angular quantities like angular velocity, angular acceleration, angular displacement, these all we have already discussed, and you know their average values and what are their instantaneous values, that we also discussed. So we have already started this kinematics of circular motion, but today what we are going to discuss is that kinematical equations of circular motion. So we'll be talking about kinematical equations. Okay. Now before that, let me just tell you that, before discussing that, we all know what is circular motion, right? And how a body moves in a circle. So if a body moves in a circle, we say that it is performing circular motion. And for performing circular motion, there has to be a centripetal force. For convenience, right now I'm just considering uniform circular motion. Well, in uniform circular motion, particle moves in a circle. Particle moves in a circle with constant speed. If speed of the particle does not change, okay. See, I am not telling that constant velocity, because velocity cannot be constant. At every point, we had seen that at every point, if a body moves in a circle, at every point the direction of velocity changes. So if the direction of velocity changes, that means velocity changes. And if velocity changes, then velocity cannot be constant. And obviously it is an accelerated motion. There is a centripetal acceleration towards the center. So velocity is not constant, because direction keeps on changing. In uniform circular motion also, velocity is not constant, but speed can remain constant. Okay. So if speed of the particle remains constant in a circular motion, it is called uniform circular motion. Okay. So I'll take the example of uniform circular motion only. And if you just tell me what is the example of uniform circular motion, then, well, there are many examples. For instance, if you consider the earth as a particle, because in the cosmos, if you look at earth, it seems to be a particle only, single particle. Okay, that big picture if you take, then earth would be like a particle. It is just moving in a circle, right? And every 365 days it completes the entire circle. That means the speed of the particle remains same, right? So this, you can take an example of uniform circular motion. Also, there is a very good example, the minute hand or second hand or hour hand, whatever hand of clock if you consider. Suppose I consider the second hand of a clock. If I consider the particle at the tip of the clock, the tip of the clock, or any of the particle, your wish. If the, that tip of the hand or the tip of the hand of the clock, if this tip moves like this, it just rotates like this, the tip is performing circular motion. Or even any other particle is also performing circular motion. And this circular motion is actually, any of the particle if you consider, the speed of the particle remains same. So this is, if you consider the tip of a hand of a clock, any hand, minute hand, second hand, it is actually uniform circular motion. So this is again example of uniform circular motion. Tip of the hand of tip of the second hand, or the tip of the minute hand of a clock, or the earth, entire earth, if you consider it a particle in the cosmos, in the big picture, then it performs a uniform circular motion. The moon performs uniform circular around around the earth. So these are certain examples of uniform circular motion, right? Is it clear? Now, in uniform circular motion, the speed remains constant. So there is only one acceleration, and the acceleration is towards center, and that is brought about by centripetal acceleration. That is brought about by centripetal force. So if particle is over here, there will be only one acceleration, that is towards the center. See, I tell you, the particle moves like this. It has the velocity, tangential velocity in this direction. Suppose this is the tangential velocity in this direction. Suppose it is moving with 5 meters per second. So it will keep on moving with 5 meters per second only, because it is a uniform circular motion, right? Now, this, there is a force in this direction towards the center. This is what you call centripetal force. And if you have force, you will have acceleration. Acceleration of a body is always in the direction of force. See, if I exert a force on the body in this direction, the body will accelerate in this direction only. If I apply force in this direction, the body will have acceleration in this direction only. So the acceleration of the body is always in the direction of force. Now we know that centripetal force is always directed towards the center. That means this is also the direction of centripetal acceleration. Yes, and you know the centripetal acceleration is at every point. Suppose your body, you know, after changing the direction, it has gone at this point. Okay, then at this point, you know, the direction of the direction of the velocity will keep on changing. The magnitude will remain same, but the direction keeps on changing. Then at every point, the centripetal acceleration will be there towards the center, which keeps on. This centripetal acceleration is responsible for changing the direction. It's actually centripetal force, and because of that there is centripetal acceleration towards the center at each and every point. Centripetal acceleration is there. Hello Aradhana Gupta, hello Dhruv Jani. So sorry, actually I did not see it. I thought no messages are there. Yes Dhruv, actually I'll teach calculus, but you know, this month's schedule has already been fixed. I'm gonna start in the month of August, calculus only. Okay, I remember. Integration, differentiation, limits, continuity. Limits, continuity I'm not gonna teach. I'm not a maths teacher, but yeah, I'll try about this integration and differentiation. I'm gonna take. Yes, yeah. Dhruv, are you there? Actually I did not see the messages. Oh god. Hello. Yeah. Okay, let's move ahead. So you know, this acceleration is your centripetal acceleration, that is towards the center. This is because of centripetal force being acted upon, being exerted or on the body at each and every point. Okay, now see, there is only one acceleration, right? See, there is, you know, apart from that we have studied angular quantities in uniform circular motion. What are the angular quantities? Angular displacement. So if a particle moves from this point to this point, it covers this angle. This angle is nothing but called angular displacement. This angle is called angular displacement. Whatever angle it covers, it is called angular displacement. Then we have angular velocity. We have already discussed it. We have average angular velocity, instantaneous angular velocity. So I am just writing general formula. Angular velocity is angular displacement upon time taken. Okay, and then we have angular acceleration. Angular acceleration alpha, that is that is change in angular momentum upon time. Okay, let me just write it over here. I think it's not visible. Angular acceleration alpha is change in angular velocity upon time. Okay, so these are the average velocity and average acceleration. If you want instantaneous velocity, instantaneous angular velocity, then we know it is V instantaneous is d omega by dt, and instantaneous acceleration, instantaneous angular acceleration alpha instantaneous is d omega by dt. Sorry, this I have written wrong. Instantaneous angular velocity omega instantaneous is d theta by dt, and it is d omega by dt. So we have instantaneous velocity, we have instantaneous acceleration, angular acceleration, average angular velocity, average acceleration. So these are the quantities that we have in circular motion. Angular quantities, they are called angular quantities. Now coming back to kinematical equations. So before before having the kinematical equations related to circular motion, Okay, we have kinematical equations that we have studied for linear motion. If you remember, kinematical equations of linear motion, what are they? What are the quantities? Linear motion. Well, three kinematical equations we had studied. V is equal to u plus at, if you remember. Now here V is the velocity, final velocity, u is the initial velocity, and a acceleration, t time. Then we have s is equal to ut plus half at square. Okay, s is the displacement, u initial velocity, again a acceleration and time, and finally we have v square is equal to u square plus 2as. This is your third kinematical equation. So first is the relation between velocity and time, second is the relation between displacement and time, and third is the relation between velocity and displacement. Okay, so these are the relations which we have already studied. Apart from this, we had studied two more equations, if you remember, but these we have derived from these equations only, and that is s is equal to u plus v upon 2 into t. Just see one more equation, s is equal to u plus v upon 2 into t. This equation also you can use as a kinematical equation. And one more equation we have that I'm going to write over here because you may not see it. Yeah, here it is. Sn is equal to u plus a by 2 to n minus 1. I hope it is visible. Sn is equal to u plus a by 2 to n minus 1. Now actually this is displacement in nth second. Okay, displacement in nth second. What do you mean by displacement in nth second? Displacement in nth second means that suppose you were asked that what is the displacement in 5th second, body is being displaced, what is the displacement in 5th second? 5th second means from 4 second to 5 second. If we've been asked what is the displacement from 4 second to 5 second, 4 second to 5 second in the 5th second, then you have to use this equation. Sn is equal to u plus a by 2 to n minus 1. Just put the value of n to be equal to 5. Displacement in 5th second means from 4 second to 5 second, right? Yes, if you are asked what is the displacement in 5 seconds, just see the words. If you are asked what is the displacement in 5 seconds, that means the person is asking the displacement in all these 5 seconds. Then you have to go for this equation, second equation. Displacement in 5 seconds, put t is equal to 5 in this equation, and then you will get the displacement in 5 seconds. But if it is asked what is displacement in 5th second, that means they're talking about displacement from 4 second to 5 second, 5th second, then you have to use this equation. So these are the kinematical equations that you have to use in case of linear motion, not circular motion. These are the translational, or you can say linear kinematical equations. And what is the condition for using this? The condition is that your acceleration should be constant. If acceleration changes, you won't be able to use these kinematical equations, because then acceleration will not remain same. You will have different equations then. Acceleration will keep on changing, then this equation will not be fixed. So if acceleration is constant, then only you can use these kinematical equations. Three main kinematical equations are there, and also among this you can just derive this equation and this equation. You can just directly remember these equations, 4th and 5th also. So it would be beneficial for you to use it. Yeah, hello Right Gaming. Hello Right Gaming. Hi, hello, welcome to the session. Dhruv, Aradhna. Yeah. Hello Prathamesh, how are you? How are you? I hope you're doing fine. I think your results are out today, right? If you're from 11th standard. Today it is Friday, so you may be from 12th standard, I'm not sure. But if you people are, any one of you are, if you are from 11th standard, I guess results are there. So they have been announced or they yet to announce the results? These year students are really fantastic because they are getting results of the exams that they have never given. No exams, but still your results are prepared. This is something which has never happened in the entire, I guess, in the history ever. Website crash, actually I was also checking it, but you know, it's not just opening only, and everyone is excited to see the results of the exam which they never gave. Yeah, website crash problem is there actually. Not an issue, we'll get the result, no problem. Even though exams are not there, still results are there. Why to worry? So now you can get results without exams also. A history will be made that you are getting the results of the exams which you have never given. Great. Okay, so let's see. Now see, these were the equations of linear motion. Now here in this case, whatever quantities that we have these quantities. In place of displacement, we have angular displacement. In place of velocity, we have angular velocity. And in place of acceleration, here we have angular acceleration. So we have three quantities, theta, omega and alpha. Okay, theta, omega and alpha. Angular displacement, angular velocity and angular acceleration. So we are going to use the same equations. We have the same equations as in case of linear motion. Only quantities will be angular quantities in case of kinematical equations. Now in case of circular motion also, if you are using the kinematical equation, the condition is that your angular acceleration should be constant. If your angular acceleration is constant, then only you can use these equations. Okay, so angular acceleration should be constant. That is the condition. Now what are the equations? Just look at the first equation over here. V is equal to u plus at. So we will write over here omega is equal to omega naught plus alpha t. Same equations you have to write. Omega is the final angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration and t is time. Now let's get back to second equation. S is equal to ut plus half at square. So here you have to write this. See, this is displacement. You will have angular displacement. Then initial velocity omega naught t plus half alpha t square. So replace acceleration by angular acceleration, initial velocity by initial angular velocity and final velocity by final angular velocity, and displacement by angular displacement simply. Then third equation will be omega square is equal to omega naught square plus 2 alpha theta. Okay, so these three equations that you already have, these are the kinematical equations which you can use. Apart from that, see, we have these two extra kinematical equations that we have derived from these three equations only. From these three equations only we have derived this. So similarly from these three equations we can derive these two equations, you know, like these two equations. We have two more equations in this case also, and they will be same. We have to use S is equal to u plus v upon 2 into t. So here you will have theta is equal to omega plus omega naught, omega naught plus omega upon 2 into t. Okay, and finally you have this equation theta n is equal to u means omega naught plus alpha by 2 to n minus 1. Again, this is nothing but displacement in nth second. This is angular displacement. angular displacement in nth second. Okay, right? So you can use all these equations in case if alpha remains constant. Okay, alpha means angular acceleration. Alpha means angular acceleration. So if angular acceleration remains constant, you can use all these equations. These are kinematical equations of circular motion, similar to the kinematical equations that we had used in linear motion that we have. So just by comparing, we have just written all these equations. Now see, you know that acceleration can be negative or positive. If your velocity increases, acceleration is positive. If velocity decreases, acceleration is negative. Similarly, if your angular velocity increases, acceleration is positive. Angular acceleration is positive. If your angular velocity decreases, angular acceleration is negative. Okay, so what will be the example of it? Okay, you can just see the example of it as you know, the motion of your fan. Okay, there you will get when this angular acceleration becomes negative and positive. And if your angular acceleration is negative, then you have to use minus sign for alpha. Okay, if your angular acceleration is positive, then you have to use plus sign for alpha. Okay, because or you can say that if angular velocity increases, alpha is positive. If angular velocity decreases, alpha is negative. So I'll take the example of a fan and then I'll just make you understand. Suppose you know you have this fan in your house. If you switch on the fan starts rotating. It has certain angular acceleration, angular velocity and angular displacement. Now when you switch on the fan, so when fan is switched on, you know, it just keeps on rotating and increasing its speed. The speed of the fan goes on increasing. Speed of the fan goes on increasing means it, you know, covers angle, keeps on covering the angle fast, and its omega increases. Speed increases means its angular velocity omega increases. Angular velocity omega increases at the start. Angular velocity omega increases at the start because when you switch on the fan, you know, the fan speeds up. Okay, and angular velocity omega keeps on increasing. Since omega is increasing, here in this case your alpha is positive. Alpha is positive because, you know, your omega increases, and hence this alpha you have to take positive in this case. Now after some time, you know, the velocity ceases to increase. The velocity becomes constant. After some time, angular velocity omega becomes constant. If angular velocity omega becomes constant, that means there is no change in omega, and then at that case your alpha becomes 0. In that case your alpha becomes 0 because there is no acceleration. There is no angular acceleration because omega is constant. After some time, suppose you just switch off the fan. When fan is switched off, you know, it slows down, right? After the fan is switched off, the fan slows down. Slows down means omega decreases. Now when omega decreases, you have to take alpha to be negative. Alpha is negative. That means your angular acceleration alpha is negative in this case. So these are the situations that we have when your angular acceleration is positive, 0 and negative. Right? Clear? And these are the kinematical equations that you have to use. These three kinematical equations are main kinematical equations, and from these three kinematical equations we can also derive this equation and this equation. Okay, displacement in nth second. Again, what is displacement in nth second? Displacement in nth second means displacement from you know, suppose I tell you what is the displacement in fifth second. So displacement in fifth second means displacement from 4 second to 5 second. So you have to see this word, what they have asked. displacement in fifth second means displacement from 4 second to 5 second. In the fifth second, what is displacement? But if they have given that what is displacement in 5 seconds, you have to see what are the words. Very important. Sometimes English becomes very important in case of numericals that are asked, because because of English also, if you don't understand the concept very well, if you don't understand what has been asked very well, you may just make the mistake. So if it is asked displacement in fifth second, you have to put n is equal to 5 in this last equation and then solve. You will get the displacement in fifth second, that is from 4 second to 5 second. But if it is asked displacement in 5 seconds, that means he is asking displacement in all the 5 seconds that was spent. So then you have to use the equation second one. Displacement, or you can say angular displacement. Angular displacement in 5 seconds, go for second equation. Angular displacement in fifth second, go for last equation and put n is equal to 5 in that equation. Then you will get the answer. Okay. Apart from that, I have already told you that instantaneous velocity is d theta by dt and instantaneous acceleration is d omega by dt. This also you have to remember. Okay. Now let us solve some questions on it, then you will get a good idea of it. So this is one of the questions that I have taken from your textbook. Let's try to solve this and let's see how we can just do that. Yeah. A fan is rotating at 90 rpm. It is then switched off. It stops after 21 revolutions. Calculate the time taken by it to stop, assuming that the frictional torque is constant. See, a fan is rotating at 90 rpm. So let us first see what this rotation. RPM means it is frequency. RPM means rotations per minute or revolutions per minute. Okay, since it is rotating, I'll just take rotations per minute. So per minute, every minute it rotates 90 times. So this is the frequency, 90 rpm. Okay, now frequency has SI unit hertz, and hertz means rotation per second. So we have to convert this in per second. So now in 1 minute it rotates 90 times. So in 1 second it will rotate 90 by 60 rps, and rps is nothing but hertz. If you write rps, it is fine. If you write hertz, it is also fine. Hertz means rps, that is rotations per second. So per second it will rotate 90 by 60, that is equal to I think 1.5 hertz. That is the frequency. That is 1.5 rotations per second. Okay. So in 1 minute it rotates 90 times. So in 1 second it will rotate 90 by 60 times. So you have to divide it by 60. So now I have the frequency of it. Now this is the initial frequency it has. This is the initial frequency it has. So initial velocity, what will be the initial velocity? Initial velocity, angular velocity, sorry, initial angular velocity. Okay, so what is initial angular velocity? Omega naught is equal to 2 pi. See, there is a formula for angular velocity, 2 pi n or 2 pi by t. N is frequency, t is time period. So whatever equation that you have, you can use this equation. I'll just use 2 pi n because frequency is given. So it is 2 pi n, and that is equal to 2 pi into what is n? 1.5. Now what is 1.5 into 2? It will be 3 pi. So 3 pi radian per second is the unit of angular velocity. 3 pi radian per second. That is initial angular velocity. Now it is said that it is switched off. If it is switched off, after some time it will stop. It stops after 21 revolutions. It stops after 21 revolutions. Since it stops finally, so we have final angular velocity to be 0, because finally it stops. When it stops? After 21 revolutions. So you have been given the angular displacement theta also. See, in one revolution it performs the total. If it completes one revolution, just one revolution, the total angle covered is 360 degree, that is 2 pi radian. It covers total 21 revolutions, that means total angular displacement is 21 into 2 pi, because in one revolution angle is 2 pi radian. So in 21 revolutions it will be 2 pi into 21. Now that will become 42 pi radian. Okay, 42 pi radian. Is it okay? Yeah. So now we know theta. Also we know initial velocity omega naught. Anything else? Frequency, we don't use it in kinematical equations. So we know omega naught, we know theta. And what is asked? Calculate the time taken by it to stop, assuming that the frictional force is constant. Yeah, we also know final velocity, final angular velocity. So calculate the time taken by it to stop. So you have to calculate the time. And it is written that assuming that the frictional torque is constant. Now see, because of torque there will be acceleration, angular acceleration. Because of torque there will be angular acceleration. So if torque is constant, angular acceleration is also constant. So they have given that angular acceleration is constant. They have themselves given it, and they have just mentioned it in a code word. Torque is constant. But we know, we are also smart. If torque is constant, then acceleration will also be constant, angular acceleration, because angular acceleration is produced by torque. So if your torque is constant, your angular acceleration alpha is constant. And if your angular acceleration alpha is constant, you can use the kinematical equations that I have listed over here. Oops, sorry. What are the kinematical equations that we have just listed? Let me just show you. See. So these are the kinematical equations that we have. Omega is equal to omega naught plus alpha t, theta is equal to omega naught t plus 1 by 2 alpha t square, omega square is equal to omega naught square plus 2 alpha t. Apart from that, we have these two equations, or you can just directly use this equation. And let us just see that which equations is needed over here right now. Now as you can see that we have omega, omega naught and theta. Three things we know. We know omega, we know omega naught, we know theta, and then we just have to find t. So omega, omega naught, theta and t. What is the relation between them? Omega, omega naught, theta and t. Just see this equation. Omega, omega naught, theta and t. Use this equation to get the time. Theta is equal to omega naught plus omega. Theta is equal to omega naught plus omega upon 2 into t. What is theta? 42 pi. What is omega naught? Omega naught 3 pi plus 0 upon 2 into t. So this will become 42 pi is equal to 3 pi t by 2. So t will be equal to 42 into 2 by 3. So what is t then? So it will be 14, right, multiplied by 2, or 28 seconds. So at 28 seconds it completes 21 revolution. Very simple. Yeah. Now one more thing, you can just do it in either way also, right? I'll just solve the either way. You have to use two equations then, but then you'll have the clarity over the concepts. That's why I'm solving with the second method also, or the alternate method also. What is the alternate method? Let me just erase everything and then I'll just show you the alternate method of it. See, you have the equations. Okay, we have the equations like, if you just want to use these three equations, then you have to use two equations to solve the same problem. I've just used one equation of theta is equal to omega naught plus omega upon 2 into t, and I just got it solved. But if I want time, I have to use two equations over here. Which two equations? See, we have omega naught, omega that we know, and then we have to find t. Okay, omega naught, omega and theta that we know. So what you can do is that you can just use second equation and first equation to solve it. If you use second equation for first equation, then also you'll get the same answer. But the problem is that you just have to use twice. You just have to use two equations. But that equation which we used, we only used one equations. So that is the only difference. So I'll use third equation. See, we have this, we had already calculated, frequency was 90 rpm. We had just converted it 90 upon 60 hertz, and that is equal to 1.5 hertz. Then we had theta is equal to 21 revolutions, 21 into 2 pi, that is equal to 42 pi. Okay, calculate the time taken by it to stop. It stopped. Now omega naught was 2 pi n, and that was equal to 2 pi, what was n? 1.5, and that is equal to 3 pi radian per second. That was omega naught, or initial velocity. Final velocity is 0 since the fan stops, and angular acceleration will be negative in this case. What is angular acceleration? Okay, angular acceleration is not given, but it is constant. It is given. Torque is constant, means angular acceleration alpha is constant. Now use the first equation. What is first equation? V is equal to u plus at, or sorry, just don't use first equation, use third equation. What is third equation? Omega square is equal to omega naught square plus 2 alpha theta. Just use the equation. Okay, so you'll have omega square, that is 0 square, is equal to omega naught square, that is 9 pi square, plus 2 alpha, and theta is 42 pi. Okay, so now you can write it as minus 9 pi square is equal to 2 alpha into 42 pi. So pi gets cancelled. Yeah, pi gets cancelled, and it becomes alpha is equal to minus 9 pi upon 2 into 42. Okay, then 3 3s are 9, 3 14, 3 upon 28. Alpha is equal to 3 pi upon 28, minus 3 pi upon 28 radian per second square. Here you have got alpha. Once you have got alpha, now you can use this first equation to get time. What is the first equation? Omega is equal to omega naught plus alpha t. So what is omega? Omega is 0. Omega naught is, what is omega naught? This is your omega naught, 3 pi. Okay, plus what is alpha? Alpha is from here. Now see, here alpha is negative. Why alpha is negative? Alpha is automatically coming out to be negative because your angular velocity decreases. Because the fan is switched off, the angular velocity will keep on decreasing, and finally the fan will stop. So I will just write minus alpha, the value of alpha take from here, minus 3 pi upon 28 into t. So therefore 3 pi is equal to 3 pi upon 28 into t. This gets cancelled, and t is equal to 28 seconds. So again you are getting the same answer, 28 seconds, with this method also. In this method you have to use two equations, but the fourth equation that we used in the previous method, you can just directly get the answer with that method also. So that is all about kinematical equations that we have in circular motion. So there's an announcement, many batches have already started of Unacademy. You can just join these batches and boost your preparation. Ramanujan batch, it's a bridge course for mathematics in Hindi. Then there is Uday PCB batch, delivery in Hindi will be there for physics, chemistry and biology. Then full syllabus batch is also going on for physics, chemistry, maths and biology. So classes are there in English, Hindi, Marathi, whatever language that you prefer, you can just join, and just listen to the lectures in your own language, right? I am also taking a full syllabus batch. Okay, I am teaching physics on Unacademy, as you know, and then this batch I am teaching Acumen batch for class 11. Full syllabus will be covered in that. Okay, this Parangat batch is also there, that is delivery will be in Marathi. Okay, again full syllabus for maths, physics, chemistry and biology. One more announcement, that there will be free test series every Saturday and Sunday. Okay, you can give this test and just check your preparation. Whatever whatever offers that you have to avail, these are the offers that you can avail over here. And whatever batch that you join, whatever subscription that you buy, please don't forget to use this code SIRSJ, SIR SIR SJ. If you use this code, you will get a 10% discount on any of the subscription that you buy from Unacademy. So these are different plans, different affordable prices that you can have at different affordable prices that you can have. You can have plans for 24 months, 18 months, 12 months, 6, 3, 1, as you wish. And it's easy to subscribe to Unacademy Plus. You can choose a payment method among them. You can also pay in installments. Zero cost EMI is also available. So easy to join. Just join and crack the exams and boost your preparation for the exams that you are preparing for. Okay. Thank you very much. Thanks a lot.